Hello, my name is Yury, and I'd like to present you our topic, KLogic, an implementation of miniKanren in Kotlin. There were my colleagues, Dmitry Kosarev and Dmitry Boulytchev from State University from St. Petersburg, and my work colleagues, Dmitry Ivanov and Denis Fokin. Why do we want to implement miniKanren in Kotlin? Actually, there are few motivation points. First of all, the whole JVM platform is very popular as well. For example, Java is one of the top 5 used programming language according to the JetBrains statistics survey from 21st year. And actually, although functional languages could be very popular for science, they are not widely used in the production. For example, JVM functional language Scala is used only with 3% of developers. Haskell is used with 2% of developers, and so on. So we would like to implement miniKanren in imperative language Kotlin, and we were inspired by implementation of miniKanren in OCaml, which is called OKanren. There are a lot of useful code in OKanren, so we want to port it from OKanren to Kotlin to use it in our production code, and somehow help developers that are not very familiar with functional programming, with relational programming, to be more familiar with miniKanren. So we chose Kotlin as a target language. Okay, we have implemented some key features, mostly taken from OKanren implementation. First of all, it contains strong typed logic layers and variables. What does it mean?
Yury, can you hear us?
Yeah.
Sorry to interrupt you. We had some audio technical problems on our end. We couldn't hear you for the first few minutes. I'm afraid I'm going to have to ask you to start over again if that's okay. We do have 45 minutes, so I think it'll be okay. So my apologies for that. We had some problems with the audio.
Oh, okay, that's a problem.
Oh, also one more request. If it's possible, if you have a video camera or if you're in a location where you can share the video, we can't see you right now. So if you're willing to turn on the video, that'd be great. Okay, great. Okay. Thank you, Yury.
Yeah.
All right, so let me do the intro real quick again. So we have Yury Kamenev, part of the very capable team at St. Petersburg State University in Hawaii. Will be teaching us about KLogic, which is miniKanren in Kotlin. So, all right, thank you very much, Yury, and looking forward to your talk.
Yeah, thank you. Can you hear me right now?
Sorry, say that?
Can you hear me right now?
We can see you. Yes, that's right.
Yeah. Okay.
Okay. Actually, if you can wait one more second. We're having a little trouble getting the screen set up exactly right.
Okay.
Okay. Well, I'll let you know when we're ready. Okay.
Okay. Let me start.
One second.
Do you hear me well?
Yeah, we can hear you. It's maybe a little quiet.
Okay.
One moment, please. We're still adjusting. Okay, I think we're ready to go. let's just do a volume check. Can you just say a sentence real quick, and we'll see if everyone can hear you?
Yeah. How does it?
I think it's a little low. Is it possible to increase the volume?
Well, I will try.
Okay. Not quite then. Can you say one more sentence, please?
Yeah. How can you hear me?
Okay. Yes, I think we can hear you fine now, and we can see your slides. Okay.
Yeah.
Thank you very much. And Yury is going to be presenting on KLogic, miniKanren', and Kotlin. Thank you.
Yeah. Thank you very much. Well, so actually, you have presented my team already. Yes. So, what does logic about? Our topic about? Well, actually, the most popular implementation of miniKanren are in functional languages, so like Haskell, OCaml, Clojure, Scala. But most programmers use imperative languages, and one of the widely used language is Java from the JVM platform. Well, according to the JetBrains survey, it is top 5 used programming language. So we would like to make more developers be more familiar with relational programming. So we would like to implement miniKanren in imperative language Kotlin that is run on JVM platform and is, well, let me say, improved version of Java, the more modern version. So we were inspired by Okanren implementation. So we have some key features. Most of them are taken from the Okanren implementation, actually. Yeah. So the first one is the most important, as we think. It is strong typing of logic values and variables. Well, what does it mean? The original implementation in Scheme, for example, has dynamic typing, so it allows users to try to unify terms of different types. For example, unifying strings and numbers or strings and lists. So it could not be successful, and we would like to check it at compile time. Kotlin is a compilable language, so we can try to use it. And we want to store type of the logic term in itself to forbid unifying terms of different types. The second key feature is disequality constraint. It allows us to not only unifying logic terms, but also we can say that logic terms could not be equal. It's very useful in some real applications that we have. So what also do we have? It's mostly about convenient usage. So we have implemented some template logic terms. So mostly logic terms contains no more than 1 or 2 values. Most of them. So we have made some templates that allows to just implement some interfaces, and you have your logic terms very easy. And the last key point is relational event observers. So we have some key events during relational programming. like unifications on terms, disequalities on terms, and some stream operations like bind or lose. So we can observe any of these events and do whatever we want, whatever we pass to these observers. For example, we can just collect number of unifications, maybe interrupt the execution, log it, or process somehow. Okay, well, there are some implementation details. This is how we implement our hierarchy of terms. Each logic term is one of two types. It could be either a logic variable that are distinguished by integer index, or it could be a logic term that was defined by user. It could be any of them, like linked lists or pairs or whatever. So it is it contains a lot of generic parameters to support strong typing of them. So as you can see here, if you are a bit familiar with Kotlin syntax, it means that any term could be a type of logic term. So any logic variable could contain only logic values. It's very important, so we cannot unify not logic objects. It's impossible to unify, for example, logic list and just a simple number from the host language. You should use logic wrapper for that. Okay, so how does process of unification look? First of all, we have two terms that we want to unify, and the current unification state that stores the current substitution of the logic variables. So to unify two terms, we need to evoke the first logic term with the current substitution, evoke the second term with the current substitution, and unify these two evoked terms. So unify impl is a virtual function defined for the logic variable and for the any custom term. So for unifying variables, we just need to look at the substitution. What does it store? To unify custom logic terms, we need to know what nodes of tree should be unified. So what values that are represented by this logic term should be unified. For example, for unifying logic lists, we need to unify each node of it consequently. It is implemented by a virtual function called subtrees to unify. That should be defined by user. So user can say what fields of this term should be unified. For example, unifying cons means unifying head and unifying the rest. Well, it is tail. Okay. But how does type checking work? There is an example of the appender relation that work on list logic lists. So you can see here that we cannot unify terms of different types. So here variable xy is list, but variable head is just element of this list. So we cannot unify list and just a single element. So here we get a compile time error. Okay, this on this slide we present how does it work in some real applications. This is taken from the client's task definition. Here we define two types of terms. It could be either symbol or sequence, and there are two different types of results. It could be closure and value. So this is just how does it work. Okay, there are some bits, some difference with, for example, Kotlin because of different type system in Java and Kotlin and Ocampo. So this is an example of defining a relation that checks that logic list is new or not. We need to put an empty list, unifying an empty list with an argument on the right side of the unifying operator, because type inference could not check that it has the same type as the past argument if we moved it as the first argument. Unfortunately, that's actually, I guess, the main difference between Kotlin implementation and KLogic implementation. Also, there are some hidden problems with delaying relations just because of different implementation. In scheme implementation and in some places in Kotlin, they used a lot of macro. But unfortunately or not, we don't not have macro in Kotlin, in Java, and JVM at all. There are none of them. So we need to implement it manually. So in recursive invocations, we need to plan to put some implicit delays to prevent hanging of the execution. Also, there is maybe a little boilerplate in implementing some relations, because we need to define type annotations for creating type variables. According to Kotlin, we don't need to define it because type system can check that we have the same type on the left side and on the right side. But in Kotlin, it's impossible. So we need to manually put, as you can see on the slide, this type annotations like element of list and logic list itself. But yes, in scheme, because it's dynamically typed, and in Kotlin with a different type system, it's redundant. Also, there are some points for the improvement. First of all, we can implement set var optimization. that is described in faster miniKanren implementation. I guess all of you are familiar with it. Also, these quality constraints are not very well optimized. It could be a bit more lazy calculated. Well, there are also some missed API methods like simple or number, but for now we think they are not very needed. On the slide, you can see some benchmarks between KLogic or Kotlin and fast miniKanren on some calculations. First of all, it's calculating the power of 3, 5, calculating the logarithm of 243, calculating 100 of lines, 15 lines, and 2 lines. Well, as you can see, actually, Kotlin works much more slower than the bracket implementation, unfortunately, mostly because of strong typing, as we believe. But unfortunately, it also works a bit slower than Kotlin implementation. But we believe that implementing some improvements that Ivan has mentioned before could help. So our future work also is just we want to find some non-trivial subtrace methods that could well show our advantage of such implementation, just not traversing the whole value stored in the logic value, but only some of them. For example, we can skip some metadata and so on. And for the more real applications, we want to implement a translator from a Kanren to KLogic, because we have a large code database from a Kanren that could be very useful in some Java applications, JVM applications in Kotlin. Well, thank you very much. That's the end of the topic. I'm ready to answer your questions.
Thank you, Yury. Let's thank Yury for the talk. And questions for Yury. We have plenty of time. Oh, there's someone, sorry, in the Zoom room. Oh, there's someone waiting in the Zoom room. Oh, that's probably for the next talk. Well, they can wait a minute, I guess. Okay, yes, Wishi.
Hi, it's Wishi. I have a question. First off, very interesting work, and I'm a little bit surprised to see the performance comparison. How come Racket is much faster than say JVM? And also, you mentioned you kind of get rid of some say symbolo constraints like those. So I would imagine if you're running coins, you're actually running fewer constraints than the Racket counterpart, right?
Well, we were a bit surprised by these equations actually, because we believe that our implementation is quite good enough. But also, we didn't profile our applications a lot. So I think there are some key places that could be improved. For example, there are some missing optimizations in implementing conjunction, for example, and in the stream implementations. So we believe that we could achieve at least the same performance as Organron shows. I don't really think that we can achieve the same performance as in Racket, but we will try.
I think this is the first time that I've heard of the blazing performance of Racket compared to OCaml and the JVM, but we'll take it. Okay. And so this is Racket, not Shea scheme, right? This is Racket, not Shea scheme.
Well, our benchmarks were mostly collected by my colleague, Dmitry Kosarev. Dmitry, could you just help me asking this question?
Usually, Shea scheme is significantly faster than Racket.
Hello, Will. Can you hear me?
Yes.
This is Racket compiled with Chess scheme backend, recent addition to Racket, compiled to native code, and it is the fastest Racket I could run on my machine.
Okay, great. All right, well, thank you very much. Other questions?
Question about this. My name is Yafan. So my question is, when you use Racket, are you using the faster Karen implementation or just the when you do this benchmark? Yeah.
Yes, it is faster miniKanren', yes.
Okay.
Okay, so you haven't implemented the set var val optimization that Michael Ballantyne added to faster miniKanren', for example. And your substitution representation, how are you representing substitutions? Oh, because you're representing them as objects, but are you doing like the hash table? I think I missed that part. Are you, for your walks, you're not using association lists, are you using hash tables or trees for a fast lookup in the substitution?
We use persistent map.
Okay.
For some substitutions, yeah.
Okay. So that should be efficient. All right, thank you. Other questions? Okay, so other than efficiency, what do you think that with the Kotlin type system, if I understand correctly, the Kotlin type system isn't as sophisticated as that of OCaml, is that right? Does Kotlin support Henley-Milner, or is it closer to the Java type system?
Yeah, it has the same type system as Java has, but yes, it's different from the Kanren'. There are no carry-forward algorithm for checking types, so it's just a bit more different.
Okay. One problem with miniKanren' in Scheme or Racket is that when you get a logic variable back in the reified answer, you can't tell what type that variable might represent unless you explicitly have a constraint on that variable, like a symbolo or numbero, or you use explicit tagging of the type. So it seems like with your type system, you should be able to tell the type that a fresh logic variable in a reified answer would correspond to. Are you able to do that?
Well, actually, the real types are removed in the runtime of execution, but well, if you had made a variable of the particular type, the type checking will allow you to get the resulting type. Actually, so
okay.
Yeah, it's very hard to lose the real type.
Okay, so you're doing something like the type erasure that's happening in OCaml. Is this something similar happens, so you don't actually see the type in the output because they're removed beforehand?
Yeah, in KLogic there happens type erasure. Okay. Yes.
Okay. That would be something I think would be really helpful for miniKanren programmers if they could somehow see in the reified answer, sort of what the corresponding type is. I think that would be helpful in terms of interpreting. I know that the compiler and runtime system can keep track of the types, but if you're looking at a complicated answer that has reified variables in it, it can be very tricky to keep track of that yourself as a human, and you might misinterpret what the types are on those variables. So that's something I encourage you to think about.
Yeah. Thank you.
Let's see. Any other questions? Okay, one more. I know that at this point we have implementations of miniKanren or miniKanren-like languages in many hosts languages. So implementations in OCaml and Kotlin and Go and Scheme and Racket and Python and all sorts of other languages. Do you think that that's something like the KLogic is better off being embedded in Kotlin, or do you think we should spend more effort trying to do standalone optimizing compilers for miniKanren as more of a standalone language? Is the benefit of miniKanren largely because it's embedded in a host language, and that's you want to combine Kotlin with a little bit of miniKanren, or do you think if we had a standalone miniKanren where we could do all sorts of optimizations and make it much faster, that would be beneficial?
Well, we believe that this implementation in Kotlin could be good enough to be used in all JVM-based projects, such as using Java or Kotlin or Groovy, or even functional language such as Scala and KLogic, just because it's quite lightweight. Well, like KLogic in KLogic is a very big library, so it gives a lot of functionality that not all developers need. I believe that this lightweight implementation could be very useful for simple for the developers that are mostly familiar with imperative languages, not with functional languages.
Thank you.
I probably answer again this question. I think we should not ask the question in the forum either we should have this, either we should have that. We should have one implementation that takes both best features of two approaches and smash them together and have the perfect implementation, which is embedded, but there are possibilities to have some domain-specific optimizations and compilation techniques during the load of relational program. Your question reminded me of the Husky, where we can have in a library specify some API and also specify some rewrite rules which allow compiler to optimize some domain-specific calls of our functions using our domain. So in case of miniKanren, probably it is an interesting idea to study this approach and to write relational programs, write down some properties of the relational programs, and later compiler should be able to somehow rewrite relational applications of relational programs together and optimize something using this human-provided domain-specific knowledge about the domain.
Thank you, Dmitry. Okay, I think I've got probably one more high-level question, which is the biggest library I know of, which is on the JVM, as you've already mentioned, for miniKanren is core.logic, David Nolan's project, and there was a successful startup company called ThreatGrid that based their product on miniKanren and ran miniKanren on a cluster and all these things. And they were sold to Cisco for a lot of money. And the way people in the Clojure community use core.logic is more like a traditional Prolog, or maybe also kind of data log. And the people in the Clojure community are very pragmatic. They don't seem to care about relational programming as much, and so they don't care about things like relational interpreters. They think it's funny or interesting, but that's not really why they are interested in a language like miniKanren. It's more that they want to have very practical uses. So do you think in Kotlin, the sort of the non-logical operations like conde and condu and project and the equivalents of cut, all these non-logical things, copy term, do you think it's important to have a library in Kotlin that has all the non-logical operators or extra-logical operators, or do you think it's important to stay purely relational?
I just want to say that it's very difficult for common developers to use some libraries that are taken from the another paradigm. For example, we had a project that written in Java and Kotlin. They are mostly imperative languages that was using a library from Scala. And for all my colleagues, it was extremely difficult to use it to debug this library because they are absolutely not familiar with functional languages, functional programming used in Scala. So it's like it's possible to use core.logic in Kotlin and Java, but it will be very difficult for most of the developers to debug it, to understand this code, to understand this functional code. And we believe that the code written in Kotlin will be much more understandable for them, much more simple.
Okay, thank you. Dmitry, do you have any comments?
And also about your purity question, I believe that non-pure constructions in relational language are important because, first of all, they will allow easy hacking and tracing, debugging what is happening during relational search. And secondly, it looks like from our experience, our functional relational codebase, that they will help a lot during connecting relational and functional code with group. And we very often prototype something using condo. Yes, I think it is called condo. And later we managed to write a pure relational implementation without it, but to have an ability to hack something with these non-relational operations, it is useful.
Okay, thank you, Dmitry. And let's thank the speakers once again for a very interesting presentation. I look forward to using your implementation. And